Over the course of several decades, over 1,000 different studies have been released showing that EMF, our wireless wonderland, has various negative effects on our health. But you might be asking the question, well, how? And that's fair enough, because when you think about it, if you have 50 or 60 hertz AC, electric and magnetic field, that's very different from, say, an FM radio signal, 98 megahertz, and then you go all the way up to 2G, 3G, 4G, 5G, which can reach as high as 5 or 6 gigahertz. So instead of 50 cycles per second, you're talking about 5 billion cycles per second. And you're also talking about very different power levels. So yeah, how? How does this wide range of different EMF frequencies and power levels, how could it possibly affect our health? Well, the answer may actually be our DNA. Hi, welcome back to Scotty's Tech.info. I'm Scotty with my co-host Cletus the Tribble, who's back from vacation. In my hand, I'm holding a fascinating paper from 2011 entitled DNA as a Fractal Antenna in Electromagnetic Fields. It is by Martin Blank and Reba Goodman. Now, before I get into the nitty-gritty details of this paper, first of all, let's think about the title. I mean, we all know what DNA is, right? Electromagnetic fields, that's pretty self-explanatory, but what the heck is a fractal antenna? Well, first, let's have a little review on antennas. So this is an antenna. It's literally a conductive piece of metal, right? That's an antenna. And at lower frequencies, you need a longer antenna due to the wavelength and a bunch of hairy stuff I won't get into. When you have slightly higher frequencies, the antenna length becomes shorter. And at very high frequencies, the antenna length becomes very, very short. So for example, at gigahertz frequencies, those used in Wi-Fi, Bluetooth, your smartphone, that kind of thing, you might have a wavelength of a few centimeters, so your antenna length will be very, very short. But antennas are optimized to receive signals at one frequency. And as we know, very often you have a smartphone, it needs to support different networks, different frequencies, different bands. So what if we could make an antenna that received 3 different frequencies? Well, you can if you do something like this. You just kind of join these 3 antennas together and boom, you've got an antenna that's optimized for 3 different frequencies. Okay, not really, because it's a lot more complicated than that, but you get the idea. If you combine several antennas into one, it can receive multiple frequencies. Okay, but what the heck is a fractal? So in this video you can see a fractal, and essentially what we're doing is we're zooming in on the fractal. And as you zoom in, eventually you'll notice that the pattern sort of repeats itself. The more you zoom in, the sort of zoomed out view is identical to the zoomed in view. So the complex pattern repeats itself down to infinitesimal size into infinity. It's sort of like a self-repeating pattern. That's essentially what a fractal is. So, okay, a fractal antenna? Well, one example of a fractal antenna is this guy. Now, you'll notice that it's kind of a complex design, and you'll see that in the middle you have one big cross. So that might be the part of the antenna that will receive low frequencies very effectively. Then, if you look elsewhere, you can see 5 smaller crosses. Okay, so that would receive higher frequencies. And then if you look again, you'll notice there are 25 of the really teeny crosses. So that would receive the highest frequencies. So this one fractal antenna is designed to optimally receive 3 different frequencies. Now it's a lot more complicated than that because usually fractal antennas use computer-aided design, and when you put multiple antennas together, it gets really hairy. But just for our purposes, we'll keep the explanation very simple, and you just have to understand that fractal antennas are designed as essentially broadband antennas. They are capable of effectively receiving a broad band of frequencies. And you might be surprised to know that very likely you are holding, or you have in your pocket, a smartphone right now. And most likely that smartphone has a fractal antenna built in. This makes sense because your phone has to receive 2G, 3G, 4G, 5G signals. It has Wi-Fi that operates at different frequencies, and it's not very convenient to have a smartphone with 50 giant antennas sticking out of it. So what they do is they design these fractal type antennas, and that's how, say, your smartphone can receive a whole wideband frequency. Okay, now at this point you're thinking, Scotty, but you said DNA is a fractal antenna, but DNA looks like this, right? Double helix shape, like that's DNA, right? That doesn't look like a fractal antenna to me. Well, you're right. But as it turns out, DNA is apparently stored compacted inside each one of our cells. And that compacted ball, which is known as a fractal globule, has some interesting characteristics. Apparently, if you pull on any part of what looks like this knotted ball of yarn, it will actually effortlessly uncoil, and it is not tangled or knotted in any way, even though it appears to be. This makes sense because if your DNA needs to unwind and all the crazy biology stuff and chemistry stuff has to happen, if it's knotted in a big tangled ball, that's not going to work. So this fractal globule is the way that DNA orders itself to save space and efficiently do other crazy things in each one of your cells. And they call it a fractal globule because it's apparently fractal. Okay, so now you're thinking, well, right, but you said a fractal antenna and you said normal antennas are conductive metal, so electricity passes through them. So DNA might be stored in a fractal ball, but is it conductive? Well, it turns out the answer is maybe. For over 20 years, scientists have been arguing about whether or not DNA strands are conductive. In one experiment, they took a part of a strand of DNA and they anchored it to a gold surface with a buckyball or some craziness like that, and they had this gold pyramid probe and they were able to pass a current through it, and they said, yes, DNA is conductive. Other scientists came out and said, no, DNA is not conductive. The smartest of all the scientists said, maybe if DNA is stored in this fractal ball and depending on the configuration, it becomes conductive or non-conductive. Sometimes it's a conductor, sometimes it's an insulator. So perhaps the reason they've been arguing endlessly about whether DNA is conductive or not is because sometimes DNA is conductive and sometimes it isn't. So apparently, depending on our genes and any DNA damage you might have, our health, it seems that DNA as a fractal antenna can in fact receive a whole slew of different frequencies. And this might explain why in the book Invisible Rainbow by Arthur Furstenberg, he talked about how over the course of technological development, first we had electrification and there were various health pandemics that occurred. And then we had the introduction of telegraph wires, and then we had phones, and then we had the first radio systems and transmitters and radar and cell phone networks. And as each one of these technologies was introduced, he could match it to a certain surge in health issues among the human population, and also animals and bees and everything else. This kind of gives an explanation as to why, because if you have DNA, and DNA is acting as an antenna that absorbs all, or that can absorb all these different frequencies under the right conditions, then, well, there's your explanation. How is it possible? That might be it. But back to our paper, DNA is a fractal antenna in electromagnetic fields. I want to just kind of read you a few little excerpts here. With EMF, studies show a cellular stress response. In other words, cells see EMF as essentially a toxin, or as the same thing as radiation, so they protect themselves. And there are actually 3 different responses depending on the level of the threat. So the idea is that certain EMF will cause a stress response, right? Just like ionizing radiation. Certain EMF will cause a single strand break, and other EMF can cause even a double strand break in your DNA. And they note specifically that many studies have shown that the damage that EMF causes appears to be similar to that of ionizing radiation, as in X-rays, gamma rays, what we typically refer to as radiation. Now, of course, for over 20 years, scientists have been arguing whether DNA is conductive or not, and so we can clearly see why we haven't actually gotten anywhere. They're also clinging to things like evolution to explain everything. Now, the idea with evolution is that mutations occur, and some mutations are beneficial, and there you go, that explains everything, you're done. But if you read books like Genetic Entropy, you'll discover that when a mutation occurs, 99.999% of the time, it's actually a bad mutation, not a good mutation. So that kind of takes the whole theory of evolution and completely blows it out of the water. And this doesn't really surprise me, because when I learned this about DNA as a fractal antenna, and I thought about that fractal globule, that ball that it's not actually tangled, but it unwinds and winds just effortlessly and is never actually knotted up. What I thought of was actually a computer chip, because you have parts of the DNA, depending on the configuration, because first of all, it's constantly in motion, apparently. Second of all, depending on the configuration, parts of it are conductive or not conductive. kind of like switches in a microchip. The switch is on, current passes, that's a 1. It doesn't, that's a 0, right? Okay, that sounds like a switch. Put multiple switches together and you get a logic gate. Put multiple logic gates together and you get, a computer chip essentially. But I'm pretty sure that Mother Nature didn't have binary code in mind when she was designing our DNA, right? So, okay, but it's also an antenna. It's not, so it's like a 3D, is it an information processing thing? Is it just a reconfigurable antenna? It appears to be a fractal antenna at the very least. And of course, the big question is like, what the heck is it receiving EMF for? I mean, I'm pretty sure it wasn't designed to receive a text message from your significant other, or a cell phone call or something. So what is it designed to receive? Obviously not the radio waves and other electromagnetic fields from our technology. So is it supposed to receive consciousness? Is it receiving, information from the information field? What is it receiving? I mean, this raises more questions than it provides answers, but it does actually provide answers to certain questions. It provides an answer to the question of how EMF of all different types can affect our health. It explains those over 1,000 studies. It gives an insight into the complexity of the human body and the fact that we understand very little. Like I said, our scientists are still arguing over whether DNA is a conductor or not. And you're going, well, sometimes it isn't, sometimes it isn't. Done. I mean, apply common sense, do real science. And the step number 1 is to look at all the data that you've got and go, okay, what does common sense tell me? Not what does evolution tell me, not what does the funding from my sponsor tell me, no, do real science, think outside the box. Right, some people are obviously doing that because this paper, frankly, it blew my mind. DNA is a fractal antenna in electromagnetic fields. Who'd have thunk it? Let me know what you think in the comments below. I'll link to all the goodies in the description. Yeah, fascinating. For more techie tips, see scottystech.info. Thanks for watching. See you next time.